Yeah, we can clear that gap by 1.5 degrees.
But that's all we need.
Yeah, that's all we need. Yeah, so if we
Worst comes to worst, we start taking duct tape and wrapping it around the wheels.
Yeah.
I remember our robotics team 2 years ago, the way that our robot works is you have West Coast drive just like this, you get 3 wheels on each side, and then you make center drop, which is you put the middle wheel slightly lower so that you can turn more easily. But we didn't put center drop on it because there's like a big platform mechanism. We were like, okay, we don't want to slip around too much on it. So we didn't put center drop. Then we could turn. We were like, well shit, now we need center drop. And so the solution was to take line belts and just wrap it around the middle wheels and screw it into place with a wood screw.
That sounds
It was awful, but it worked. And we kept shredding carpets because we had wood screws sticking out of our middle wheels.
Welcome back to Maker Hacks. At this point, all the electronics were finished, all the hardware was finished, all the CAD was finished, and we were just waiting on 3D prints to come and programming.
I'm really questioning the audio quality of this recording, given that it's all the way over here and it's quite loud here. So if the audio quality is not good, then that would not be good.
Yeah.
Oh, is this one of the prizes? Is this 2.85 millimeter filament? I have honestly never seen that before. 2.85 millimeter filament.
Hi, Alex. This is my mom.
Hi, nice to meet you.
Can you demonstrate how a robot is going to work?
So this motor set right here, this is going to move the whole robot around. We're going to have wheels on it using staggered. This is safe space, so it's going to pick up some vertical space. And then we're going to have this attached to it. So this part is going to allow these two to move at independent angles. This will just control how high it is. This will control the angle of this thing. And then we can have, we're going to have it go down like that and just move to retrieve the cube. And then we can move it up and then use this to jump it and scale it like that. So that's what we have so far. We still need to do a lot of code and electrical.
Yeah.
But yeah, it's going pretty well.
Yeah. You've shown lots of I think all of the prototyping and CAD.
Yeah, I've done the CAD.
Software, hardware, and so on.
Yeah. I think I'm going to start calculating the formulas for this thing ahead of time so it's gonna be easier to implement it into the code.
I think I'll just leave them.
I didn't go over this very well in the first video, so I'm going to talk about it now. Our team's strategy was to instantly go through the gaps in the yellow cubes at the start because our robot was small enough to fit between them, grab 3 cubes on their side, go up onto the platform and dump the cubes on the top of the scoreboard because that would give us the most points. That's why we made our robot so small, so that it would fit both on the ramp and in between the gaps.
With this one, like ideally, we want it to have a range of motion that's like from straight down to straight up. Because it needs to go down a little bit to be able to pick up the cubes.
So this is mounted just like directly on top?
This is, I mean, we'd
Or
want
is
it
there a
to
piece underneath?
there's gonna be the plate underneath it, and
Is
then
this just the plate underneath
and then
it
yeah,
that's
and then it's
mounted?
directly on that, yeah. This is the first time the whole hackathon when I drank normal water.
Dude, stop drinking Pepsi.
just go to sleep when I'm tired, but I'm not tired right now.
Perhaps there's something to do.
Maybe.
Just a thought.
Just a thought.
Just an idea.
Yeah.
We started to program the motors and the servos so that we could move the robot as well as turn it and use the spatula to pick up and drop the cubes. We ran into quite a few problems with the motor drivers, however, though, one of them being that we didn't have access to any solder. Super glue would make it not conductive, so basically we had to duct tape the wires onto the holes to try to get it to stick, and it still wouldn't stick. If I lose this hackathon, then I'm going to be blaming the lack of good materials instead of my own lack of skill.
Okay, so we don't need that whatever pin it was.
Yes. I think we would need that if we wanted to be able to adjust our speed. However, I don't care. And I'm not going to fix it.
This is the actual overnight part of the hackathon where all of my teammates went to sleep except for me. I was there desperately trying to fix our thing. One of the organizers came to me in the middle of the night and said that our top plate print had failed, so halfway through the night, I started gluing together cardboard from pizza boxes to desperately get us a frame on top. I glued one servo incorrectly 3 times, I think. Wires kept disconnecting. Things kept breaking. And I couldn't be productive because I was just tired, but I couldn't fall asleep. So half the time it's just me sitting there playing Tetris.
Okay. I've tried doing a little bit of stuff. The print failed and we don't have enough time to get another one, so I made this cardboard plate and this aligning thing. So when that dries, we can glue everything. I glued these on, so we can also glue that. Like, I think, let's do the wheels. Let's do the frame first and then we can do the wheels. And then we can do electronics on top, and then I tried figuring out something here, like, but then the controls, like, I don't know how to figure that out. Maybe you can try to figure that out.
It's so quiet compared to last night.
Maybe people don't want to wake up early.
Yeah.
That's probably it.
Did you go to sleep?
I took a few naps.
At this point in the hackathon, we had about 3 hours left, but none of our controls were set up yet, so there was a lot of work to be done.
Oh, it's 8:27 already. Don't hear that at 11. We're almost out of time. This is how every project ends. It's just at the start you're designing for every case in case you want to change something later, and at the end you're just gluing random crap together to make it work.
At this point, I was so desperate to get things working, and I was so tired that this ended up happening.
Shoot, I spilled the chocolate milk. Paper towel. Starting to default to that one rotating again. Yeah, whenever it gets unplugged from a computer, it just defaults to that one rotating. I don't know why. disconnected wire. Oh no, some motors got disconnected. Oh no. Get some taping stuff done.
How you guys doing?
Not very good.
Not very good. Can I help with anything?
Currently having some.
Can you give us more time?
Yeah, that's not me. I'm not there.
And then we're trying to get it to connect wirelessly.
Yeah.
But that's not functioning right
Not
now.
functioning? Yeah.
And we can't figure out why it's not functioning. So
Yeah.
You're going through the Wi-Fi? Through the century Wi-Fi?
No, we're having it create
So it's
its own
supposed to do its own Wi-Fi,
Okay.
and then we have a web server in between. So
Okay.
in theory, we should be able to send stuff to the web server, have it sent back to there.
In theory.
Except for we cannot connect to the web server, and we can't figure out why. So
The web server is on the ESP.
Yeah, we were able to do it yesterday.
but now we can't. What changed? Nothing. In theory, clearly something changed. It's not working. But
Have you tried flashing it?
Oh, that's a good idea.
we could try that.
Save your code, your working code somewhere?
Oh no, wait. Oh my
Yeah,
god.
I can save it.
This last hour, I was so tired that I didn't even feel like I was building the robot anymore. I felt like I was watching someone build the robot.
Oh, you're covering it.
Yes, I am.
Is everything connected well?
Yeah.
It's always in here. If I just put some of these heavy nails here, that might keep the switch for no.
Can you not just tape it down more securely?
I've already taped it down quite securely. It's still being weird. I've taped it down like 4 or 5 times at this point. It's just not. If worst comes to worst, we can just like cross the first 2 lines and
We could
the
also-
opponent screws up.
We could also use buttons.
Or if we move and the opponent doesn't, then we win.
Yeah,
However, that requires A, the opponent not moving, and B, us moving.
By this point, I was really starting to panic about whether or not we were going to be able to even finish our robot, let alone the features we were going to add.
Everyone, submissions are due in 45 minutes. 45 minutes.
We weren't able to get the control web server to work, and whenever I unplugged the cable connecting it to the computer, it would just default to one wheel spinning and doing nothing.
Why? Why? Why does it not work?
Maybe we can organize.
Oh, I'm never running set command. That's my bad.
Okay, I think I got all 3 spatula commands working,
Good.
but I'm like, there's an issue with the front wheels.
Why?
The front wheels are not turning for some reason.
Oh, let's have the buttons in.
Ugh! Stupid wheel!
And then, hold on.
We were really running out of solutions, so we decided to ask one of the organizers if we could just control it with the cable connected to the computer. And he said yes!
It doesn't work though.
Reload. Forward. Left. Right. Okay. Okay. Now, how do we send this to that?
Oh yeah.
No
We
idea.
have
Given that, like,
5 minutes.
wow.
At least it's not 5.
That's true. It could be worse.
There's just stuff getting into the way of these 2 wheels, which are preventing them from turning, which is not good because we really need maximum power if we want this thing to work.
But we need to know what we can.
Okay, 3 out of the 4 wheels work, which is okay. It's not good. That's a problem.
Okay,
Because
so say we just set it to run forward. You hit start on the computer, you unplug it.
Everybody, sign in to the death post within the next 7 minutes, or else you won't be able to participate.
Alright.
Check the Discord announcements. You need to submit your project by 11 a.m.
So it turns out I lost the video of the first robotics match we had, but safe to say we lost given that the majority of our systems didn't even work. So we were brainstorming methods on how we could potentially win the second match, and one of our wheels had completely stopped working and it just wouldn't turn. So what we decided to do was place the robot directly in front of the yellow cubes, knowing that it was going to veer off to the side.
Anyone who's not on drive team, please stand behind your driver. You're going to be starting match 4. This is the first match of the loser bracket. On the blue team, we have the push machine, and on the red team, we have red stick. This is the first match 4 of the loser bracket.
Stop after 7 times.
Okay. Get ready to run.
On the screen, we'll start in 5, 4, 3, 2, 1, go.
It did not. Oh wait. We crossed, but wait, does that count though? No, but
5, 4, 3, 2.
okay, start. Does that count? Like, does that count towards their minus? Because they touched it, we just made them touch it. Yeah, we're trying to.
Turn to the left, drive to the left.
Yeah, you got it. Wait, does that count as blocking?
We're trying to. Stay, just don't do anything. Jenny, just stop the boss.
Oh yeah, that does.
Jenny, stop, don't stop the line.
Did it lose connection?
I'm not sure.
Do you think?
Oh my god. Oh no. Who would have known it would have went straight? Well, what can we do? What can we do?
1 second.
The blue thing lit up, but they should, but like it's not doing it. Oh my god.
9, 8, 6, 5, 4, 3, 2, 1. Red team has won the match with a score of 19-0.
Yeah. So now I know what kind of music to play in this vlog.
Match 7 loser bracket. Next up, we are playing match 5.
Okay, now that we know what the result is, I'm going to proceed to blame literally everything except for my own lack of skill, like I said before. I had no access to solder during this hackathon because the venue didn't allow it, so that stupid wire kept getting disconnected. There was only one bottle of super glue for everyone in the whole hackathon, so I had pretty much no time to glue anything. Half the 3D prints from the 3D print farm failed, and the ones that didn't have supports removed, and I didn't have any tools to remove the supports with. But honestly, none of that would matter because everyone else had the exact same materials as us. Except for those who smuggled in their own materials.
Okay, so for both your winners, which are completely decided by peer voting, we have in first place, Dialmate. Small issue, only one of you is registered as a contributor to the project. Okay, so number 2, we have Bungalow. Smart home security system date symbol. And in third place, we have Inferno Watch with 11 points. And now, one moment.
Now I'll be announcing the winners for the open prototype project. Okay? So in third place, we'll be receiving a mechanical keyboard. We have Knocklaw. Congratulations. Now in second place, you guys will be receiving a 3D printer and an Arduino kit. We have TileMate. And finally, in first place, you guys will be receiving a 3D printer, a speaker, and a lamp. We have Anteaters. Congratulations, guys. I'll be handing it over to Funny now.
Yeah, thank you so much to our partners Hack Club and Sentry for being the reason Maker Hacks became a reality. You are the reason we have this amazing venue to host the first ever Maker Hacks. We truly could not host Maker Hacks without your support. Thank you, and now moving on to one last word from my fellow organizer, Doreen Carlaker. And with that, Maker Hacks has officially finished. Good job to all of you for all your hard work on your projects, and thank you for everyone here for participating in Maker Hacks. This event could not happen without you. Everyone here is free to go.